Good morning. Today we're going to be starting our second to last chapter for the year in physics. It's about waves. The chapter is called Mechanical Waves and Sound. We may not get into the sound, but we'll do at least the first 3 lessons so that you can understand what waves are. We might use sound at the end just as an example of what we learned. Okay, so the first thing we want to talk about is something called mechanical waves. Now, bear in mind, we may have mentioned electromagnetic waves before, which is the one that comes from the sun. Today we're talking about mechanical waves only. Okay? All right, so what is a mechanical wave? It's a disturbance in matter that carries energy from one place to the other. What does that mean? A disturbance in matter. It means that in solid or liquid or gas, there's a disturbance. There's some kind of energy that is being shifted from one place to the other. So the energy is moving through this matter. It's moving through a solid, it's moving through a liquid, it's moving through a gas. So we say waves carry energy, okay? And you can see the effects of waves and how they carry energy. For instance, if you're in the sea, and how a wave can actually carry a ship up or carry people as it's moving, yeah? So that's how much energy it can carry, or it is carrying sometimes. Now, waves are all around us all the time, okay? But they do require matter to travel through. So if there isn't a medium for them to travel through, like solid or liquid or gas, then how's the energy going to get, transported from one place to the other? Okay, so we call the matter that it travels through, whether solid, liquid, or a gas, something called a medium. It's where the energy can travel through in the form of a wave, okay? For instance, when you see waves in the water or in the sea, that means the water is the medium. If you're playing with a rope, okay, and you're making these waves in the rope, then the rope is the solid and it's the medium, okay? When we speak, our voice travels through air, so the air in this case is the medium. Okay. The wave starts when there's a source of energy that causes a vibration to travel through this medium. So something has to happen, some kind of source and then the energy will the source of the energy, and then the energy will travel through the medium as a vibration. Now, vibration means there is some kind of, movement, whether back and forth or up and down. So to vibrate means to go in opposite directions in a very short period of time, right? So if I do this, I'm vibrating, yeah? So vibrate up and down, vibrate left or right, sideways, doesn't matter, but in opposite directions. So we say that the definition of a vibration is a repeating. So it keeps repeating back and forth, back and forth. So back and forth does not indicate direction, which is great, but it just means going in opposite directions. That's a vibration motion. So for instance, again, if you shake a rope, okay, so you're putting energy in the rope. If I'm creating a wave with a rope, you're putting energy from one end, and then it travels through the rope. Okay, the energy gets traveled through the rope, and it is going to be vibrating because the rope keeps going up and down and up and down, and so that's vibrating. It's going up and down, right? So when these waves travel through any medium, we've classified them scientists have classified them into 3 types: transverse waves, longitudinal waves, and something called surface waves. We're going to talk about each one and how the vibration in each one works. So the first one is a transverse wave, and let me just give you a hint here. Transverse is T, okay? And in the letter T, they are perpendicular to each other. If it's a lowercase t, then you might see it a lot more easier. So there's perpendicular. What do I mean by perpendicular? If in the rope, you'll notice that the rope keeps going up and down and up and down. But in what direction is the energy traveling? It's traveling this way. Yeah? So the up and down motion of the rope is perpendicular to the direction of the energy or the wave itself. So the wave is moving this way, yeah? But the vibration is going up and down. So you see the perpendicular, the vibration is going this way. Sorry, the energy of the wave is going this way, but it's traveling up and down, yeah? So as it's traveling, Okay, it's going up and down. So they are perpendicular. That's why I'm saying transverse is the one where it is perpendicular. The T helps you to remember that it's the one that is perpendicular. Okay? Now, here's some expressions that you guys need to really remember. Okay. Now, the top of the wave in a transverse wave is called the crest, and the lower point is called the trough. And in the middle is the resting position. So again, as it goes up, crest, resting position, trough, resting position, crest, resting position, trough, and so on. Okay, so please remember these expressions are very important. So the highest point of the wave is called the crest, the lowest point on the wave is called the trough, and in the center, exactly in the middle, is called the resting position. Okay, so again, one last time, the transverse wave is one that causes the medium, in this case the rope, to vibrate up and down in this case, or because maybe I'm doing it, so don't say up and down, say it's vibrating in a perpendicular or at a right angle to the direction in which the wave is moving. Okay. The second type is something called a longitudinal wave. Longitudinal wave. Now in this case, this is always the best example to give, a spring. So if I pull the spring from one side and I push it, okay, the wave is going to travel through the spring, okay, it's going to travel in this direction. But in this case, they're not going up and down. You'll notice that the spring parts are moving left and right. So I gave it a push from here, so this one pushed 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 this, and it went back, and so on. So it's going like this. Okay, but obviously it's happening very fast. So what you'll notice here is that it's going back and forth, but in the same direction of the wave. Yeah, it's not perpendicular anymore, it's parallel. Okay, it's in the same, it keeps going this way like that, but the wave is going in the, it's parallel to it. It's no longer perpendicular. And the way I like to remember it is a longitudinal has a lot of L's and has one L, and parallel has a lot of L's, so L and L. Okay, if you just remember the transverse perpendicular, then the longitudinal is easy. So again, in the longitudinal wave, the vibrations are parallel to the direction of the wave. Now, when the parts of the spring here, to make it easier for you to understand, are close to each other, we say they are compressed, and then they relax, and then they compress and relax, compress and relax, compress and relax, compress and relax. So when they compress this part, it's called the compression. When they relax, it's called a rarefaction. Compression, rarefaction, compression, rarefaction, compression, rarefaction. So again, you see the vibration. Okay, same direction as the direction of the wave or the energy. So you have to remember the words. Now, and remember, in the other one, this one, it was crest, resting position, trough. Crest, resting position, trough. In this one, it's compression, resting position, rarefaction. Compression, resting position, rarefaction. So they're just different words, okay? So for the transverse, crest, trough. Crest, trough. In the longitudinal, compression, rarefaction. Compression, rarefaction. Compression, rarefaction. You have to memorize them, and you're not allowed to make mistakes, spelling mistakes, I mean, with it. Rarefaction. Okay, not fraction, okay? Or not, and not refraction, because refraction is another word we're going to use in the next lesson. It's called rare, remember by the word rare, faction, okay? All right. So like I said, in this case, the coil was moving back and forth and back and forth. So the vibration is in this medium, in this case the spring, that's the medium, is parallel to the direction of the wave. Okay? Now there's a little bit of information here that maybe that we haven't mentioned. You may have, if I taught you in 8th grade, you might remember this. The waves and springs are not the only kind of longitudinal waves. There's something called P waves, which are called primary waves. If you remember, they're produced in earthquakes. Okay, they travel through Earth, and the scientists can use these waves to map Earth's unseen interior. If you remember, we used these they were called seismic waves, to understand how Earth was moving on the inside. So again, how does that work? If there's a shake in Earth's crust, get used to bumping to the rock next to it, bump to the rock next to it, bump into the rock next to it, bump into it. So you see how it's very similar to the spring motion. So it's almost like domino, but except domino stays down. No, it goes back, it bounces back again. So if it bounces back, then that's a longitudinal wave motion. Okay, so just to compare both of them, so this is the longitudinal, okay, this is the longitudinal, and this is the transverse, up and down, but this one is back and forth, back and forth, back and forth. This is parallel, but this is perpendicular to the direction of the wave. Okay, if you want to just compare them, you can pause here for a minute and just look at them again. Okay, now there's a third type of wave, and it's called a surface wave. Again, you may remember that we talked about this before in 8th grade, but if you don't worry about it at all. In the surface wave, it's a mix between transverse and longitudinal. So what happens here? Look at this image. So basically, in the surface wave, there's two mediums. There's not just one. Like if think about it, in the longitudinal and in the transverse, it was one medium. The rope going up and down, the spring. So I didn't talk about anything else. But when there's a surface wave, the surface of what? That means there's two mediums, and there's a surface of one against the other. Okay? So it travels along the surface separating two mediums. Okay? So in this case, for instance, there's water and there's air. Right? And the way that this is going to move, it's like I said, it's a combo of the transverse and longitudinal. So there's up and down, but there's also back and forth. So it ends up becoming a circular motion, as you can see here. So it goes up and in a circular motion and down again and so on. So let's actually understand how this works. Okay. So the crest, there's a transverse wave. There's a crest and there's a trough. So when the crest passes, the bob goes up, the bobber goes up. The bobber is the one that they use for fishing, by the way. And when there's a trough, it goes down. So it keeps going up and down, up and down. Okay, but at the same time, there's also a transverse wave happening, a longitudinal wave happening at the same time. So it's going back and forth, back and forth. So it ends up becoming that it goes up to the left, or back, and then down to the and forth, and go up and down. So this circular motion is what we call a surface wave. But again, it doesn't happen unless there's two medium, and this is happening on the surface of one of them. Okay, all right. There's something about surface waves. I think this is the last slide. Now, with surface waves, the bobber stays where it is. It doesn't go. If you've ever been fishing before and you throw it into the water, or even if honestly, if you're in the middle of the sea, maybe you're fishing, maybe you're in Laguna Sukhna or anything, and there's a plastic bottle there somewhere, someone trashed it. You'll notice that it just keeps moving up and down with the waves, but it stays where it is. It doesn't really move. Okay. Now, near the shore, it's different. If it's near the shore a little bit, the waves tend to throw it on the shore. Now, why do they throw it on the shore, but in the middle of the ocean they don't? There's a chance in the middle of the ocean for it to make a full circle. But the problem is, if you're near the shore, as the wave goes up and down, it counters the ground. So there's friction. So it kind of messes up the rhythmic cycle of that circular motion. So the top part is longer than the bottom part, which ends up throwing the object onto the shore. Okay, so if you're near the shore, the object actually moves. The surface wave is able to move the object. But if the surface wave has enough depth for it to happen without interference, then the object doesn't move at all. It's just up and down and up and down. Okay? And that's it for today's lesson. I hope it was easy. Take some good notes and write them down. I hope this helps you with the worksheet as well.